Hey everybody, thanks a lot for coming. So for those of you who don't know me, my name is Ryan Kotzen. I am a software engineer slash coach slash do a little bit of ops type things, and also a bit of a OpenShift cluster admin at the moment. So just to show you that life, you can't really plot where you're going to end up. But today I'm going to be talking to you about one of my passions, and that's Node.js. Although the principles in this logging talk do also apply to the browser. So for those of you who aren't working in Node.js, don't feel like you can fall off to sleep. There will be a test afterwards. Also, the concepts apply across language. So if you're unfortunate and you have to work in Java, or slightly more fortunate and you got some C#, you can go ahead and use the same principles there. Sorry, I'm just a recovering C# developer, so I've got some nostalgia for it. Whereas Java, I just have horrible, horrible memories. Cool. So I just want to get a bit of an idea what people are working on. Who of you are using Node.js at the moment in background? Oh, that's good. That's a lot more than last year. That's exciting. Cool. Everybody else, mostly C# and Java? Any Go, Clojure? Anything else? No? Ruby? A little bit of Ruby. Good stuff. Keeping it real. Okay, awesome. So what I'm going to do over here, there's no slides. I'm just going to take you through some code. So we basically are going to look at how we can do logging in Node.js or on the server side. And we're going to look at some of the best practices for it, and specifically in Node, which library is one of the best ones to use. But the concepts are fairly straightforward. So just to give you some background, when I first started developing, I was a .NET developer. So you live in the Windows world. A lot of the complexity that other developers have to deal with is abstracted away from you. Until about 3-4 years ago, I didn't even realize there was such a thing as standard error and standard out. So you go to NuGet and you install nlog and you move on with your life. The logs happen. I mean, you don't know why they happen, but you know they happen. So my journey into Node.js sort of forced me to realize a lot of what's actually happening under the hood over there. And for those of you who might not be familiar and are not ready to admit it, on any operating system, there's basically two streams that you can write to. When you log something to the console, that's generally standard out. And when you have some sort of error condition and you would like to report that goes to standard error. And there's all sorts of mechanisms on the actual virtual machine or hardware machine that'll actually allow you to then go and read those logs and report on them and figure out why your application died and everybody's screaming at you and you can't carry on drinking on a Saturday night. So for those of you who are sort of involved in the more operations side of things, not just necessarily the dev, you'll know that when there's a crisis and you need to get at your logs to figure out what's gone horribly wrong, if you've got 8 machines all running the same version of your app, and you have to SSH or remote desktop into each one to try and read the logs off of the event viewer or on the file system somewhere, it's an absolute nightmare. And that just prolongs the suffering. It's not so much of an issue when you're actually doing the dev, because you've got your console and there's generally only one version of the application up and running. So you might not be familiar with those, but if you are administering any sort of testing environment as well, where you need to do performance management or investigate issues that are happening in the test environment, this will also apply to you. So to take a look at that, we have over here a pretty standard piece of code. So we're going to log to the two different I/O streams. Console.log will write to the standard output, and console.error will write to standard error. So we'll just kick that off over here. No, I don't want to. So you'll have to excuse me. My touchpad gets in the way of typing a hell of a lot. So if you see random things pop up, hopefully it's not all offensive, but we'll get a look at that. So I'm just going to kick this off. I get to choose what type of logging I'm doing, and I kick off that console, and you'll see both of them in this case write out to the console. And that's fairly like your basic level of logging. It's fairly useful in dev, but not super useful if you are running on production without anything extra added. To just show you how that's all working, we've just got a simple map over here, array with map objects that we can loop through, and we're using a really cool little library called Inquirer, which allows you to do console apps. So if you find that you're writing lots of little tools to administer your systems, and you like the command line, go ahead and install that. The other thing we're using is .env, which allows us to load environment variables. So a little bit of a spoiler over there, what might be coming up if everything's working. You can just load environment variables directly into your console. Cool. Also, if at any point during this talk you've got any questions, feel free to stop me, put up your hand, get a bit of a discussion going, and we can see if we can't address any of those concerns. Cool. So that standard console and error logging is fairly straightforward, and it's fairly powerful, but if we're going to be running multiple systems in production, and you've been reading a lot up on the Hacker News, and you've decided that microservice is really awesome and it's going to solve the problem that you have, that problem is going to become even more crazier to try and figure out, okay, well, a web request came in, and then it went through all of one of these 60 different microservices, and what was the actual journey that web request took before it got swallowed up and died? So investigating that without a central logging system can be an absolute nightmare. So one of the most popular at the moment logging frameworks for Node.js, Node.js being quite popular in microservices, is called Winston. Anybody here using Winston? Cool, we've got a few people using it. Good stuff. So Winston is just an NPM package. We install it the way we would any other. You can set up a bunch of different levels, and you can do cool colors so that you can make your console a little bit more easier to read. You want to pick out the error in red. Obviously, you can also write those to file, but the file reader that you're looking at has to support those Unicode colors. So I've just set up some basic code because I'm going to be sharing a hell of a lot of it between the different examples. So we've got colors. They're using typical strings. I'm not sure if hash codes are supported. Then we've got the different levels of errors. Error levels are quite useful. They allow you to filter based on where the logs are going to go. So you're going to say, I want to send all of my trace logs here, or everything trace and above I want to send there, and everything that is error or fatal I want it to send to my Twitter feed so that I can pick it up pretty quickly. So you can do some interesting things with log levels over there. And then I've got a simple file over here which is going to log some stuff for us. So we've got a movies.json file that we're just loading up, fairly complicated, well, fairly straightforward object, just to see how the different options are going to handle that. And we've got some strings over there with I'm a fatal or whatever the level happens to be at that point in time. So just going back over here, we will call Winston, we'll add the colors to it, and then we will set up the log levels, and we will import the log stuff module, and from there we will instantiate a new instance of the Winston logger with all the various options that you can pass. There was recently an update from Winston 2.x to 3.x, so a major version update. If you are running this in your project, make sure you look at the right documentation because it has changed quite substantially, and that cost me at least an hour of my life while putting together these slides. And then lastly, we will call log stuff, and we will pass in the Winston logger. Cool, so let's take a look and see what that looks like. So we get some pretty colors, which is quite cool. And we get a timestamp, which is really useful. There's nothing worse than trawling through logs without a timestamp. And you can tweak the formatting quite a bit. And you'll see it's got this like sort of semi-pretty print way that it serializes JSON over there without all the braces. You can turn that off if you want actual like proper JSON, which becomes quite important a little bit later on. Cool. So logging to console, we've increased our console visibility by adding some colors and some timestamps, but we still have to log on to every box to try and figure out when something's gone horribly wrong. So the next step we might want to do is log to a file system. That way we might write some sort of parser that'll pick up all the logs on the file system and send them to a central place. It's called log shipping. So In order to do that in Winston, it's fairly straightforward. We just add a different transport. And Winston has all sorts of different transports that you can hook in, depending on what data store you might want to send your logs to. In this case, we're using a file one. There's MongoDB, there's a Redis one, Elasticsearch, and a few others. So setting up a file log is fairly straightforward. You just give it the level that you're trying to put to and the name of the file. There's all sorts of advanced options that you can set to do log rotation so that you don't end up killing your hard drive with a bunch of logs, which I experienced earlier today. So if we do file logging, all we'll see is that it's written to logs error, which I probably should have cleared so that you guys would believe me. But there should be a timestamp in there, so there's our time. And you'll see that it's logged the logs in a JSON format. You can actually control what format it's going to do and if it's going to include the colors inside your file as Unicode backtick things. Not backtick, sorry, Unicode escaped characters, which is quite useful. Now, a lot of the time while we're running our code, we will want to do file logging as well as console logging. So we might combine multiple different versions of our log messages together.
What happened to the movies in the previous log?
The movies in the previous log.
In the file log?
So if we look at the file log, I don't know. Let's see, we called log stuff. Then we did that, and then they didn't go into the thing. Oh, that's a feature. Oh. Yeah. Let's clear that out. File logging. Oh, we set a level. So movies go through the logger.debug. And if we look at the code, we said over there, under levels is equal to levels. So that'll actually set up the levels and trace. And then for file logging, so we've overridden the default trace level. And we've said only warning messages should go to file because we don't care about trace. But we could easily just go ahead and change that to trace. Actually choose the option, write those to files, and you'll see those get serialized again as a JSON object. Although it looks like there is a JSON object, but you only actually get one in total, and I can't figure out how to scroll to the right at the moment. I don't know where my scroll bar is. It helps if you turn the monitor to the right size. So you'll see it's actually not nested the JSON object inside the JSON object. It's just flattened the properties, which is not ideal. So you might want to tweak that option. But like I was saying, you might want to log to the file as well as to the console. So here we've got our console logging, and if we look in the error log, you'll see after then we've got our warnings and above. Cool. And if we look at the code for that, it's actually fairly straightforward. It's a combination of the previous two codes. The transports take in an array, and you can put as many of those as you need. You can even duplicate the same one twice. So you might want to write out, what I wanted to do was write my trace logs to one file, my errors to another. And so that I could, put different rules for file sizes on how big they can get. But it's trace level and above. So actually what ends up happening is all of the messages get in the trace file and only the errors in the error file, which might not be exactly what you want. But you can always write your own transport if you're interested. The documents are pretty straightforward. You just use Filesystem. Cool. So the next thing that we tend to do on our evolution of how we write our logs is we might want to save them to our database. Now, a very important thing when saving logs to your database is don't save your logs to the same database that is your production database. Because what happens is, firstly, if you can't connect to your database, you can't write your logs and you can't figure out why you can't connect to your database. And secondly, if you've got some code that causes an infinite loop of logging messages to go into your database, you're going to fill that thing up pretty quickly, and that's going to end up in an actual production error. So your trace logging could cause a prod error because of that. So be very careful. MongoDB is pretty good for this. SQL, not as much because it's structured data, and you don't necessarily know at dev time what the log message, let's say if you're logging a JavaScript object, you don't necessarily know the properties that are going to exist on that object. But Mongo, being a schemaless database, is fairly straightforward. So let's go and take a look at that. You'll see I didn't write to the console, so not super exciting, but in the transport, In the transports over there, we've got a MongoDB IP address and the name of the database we're trying to log to, the collection that should be used, and the level to use. So who here has used or is using Mongo at the moment? Cool, few people. So for those of you who may not be familiar, Studio 3T, it's quite a cool little utility. It is quite expensive if you're going to be using it for commercial use. So you might want to look at some of the free alternatives. If you can, get your company to pay for them. It's pretty cool. So here we've got some log messages. You can see the timestamp. And this is pretty cool because we can now start to aggregate our logs from the different places. Obviously, the servers need to be able to see the MongoDB server, so your network segmentation becomes fairly straightforward. But we can do some interesting stuff. So can you guys see that? Unfortunately, zooming is not supported in here, and Windows Plus only works in Windows. All right, so I'm going to type in some simple JSON over here to just do some queries. So I want to say, give me all of the messages where the level of the message is equal to error. So we can go and run that query, and we can just get the errors out of there. That you can then say where the level is error or equal to fatal, because generally you'd want to get those together. And you can start saving those queries. You can even, if you're super adventurous, build a React app on top of your MongoDB to just look into your logs. Don't do that. There's actual stuff out there that you can just install. But if you're crazy, you can. No, it doesn't. That's the beautiful thing about storing it to Mongo. So if we take a look, it looks like a database record. So if I remove this filter, it looks like we've got a whole bunch of database records over here. But let's go ahead and delete those and actually dump an actual complex object into there. So let's put the traces into the database. Cool, that's done. Rerun our query. And you'll see we've got some over here with a message. Now, if you look at it and you're used to seeing a SQL table, you're like, oh, well, the message is blank. But actually, if we go ahead and show the embedded fields, well, there's a few different ways you can look at it. So this is the table view. There's the tree view, which will show you, okay, well, we can expand this tree and dig a bit down. And there you can actually see the object. And then there's the actual closest to what Mongo is actually doing, which is the JSON view. And you'll see here, this is what it's actually storing in the data store. We've got a nested object, and because that's just well, it's technically BSON, which is binarily serialized object notation, which basically will store that object instead of as a string, which is not super efficient, as binary. And we can see the nested fields all get included over there, which means we can then query on them. Obviously, if you've got a ton of logs in here and you haven't taken the time to put indexes on them, your queries are going to take quite a long time. But then if your data is unstructured, it's kind of hard to know which indexes to put on. But you'll sort of, as you maintain a production system, you'll get a feel for what your data's looking like and what you tend to query on. And you try and save Saturday Night Ryan some time by building these queries ahead of time. Cool. But MongoDB, while a great document store, is not necessarily designed for logs. It's fairly useful. One thing I see a lot of people doing is setting their logs up so that if an error occurs, they get an email. So the intent is good, but generally that shouldn't be a requirement of your actual code to push that through to email. Because you kind of want to set up alerts around things that are not errors as well. So if we get 10 warning messages in under a second, send an email. But maybe not for every single warning message. And there's a whole bunch of frameworks and third-party software like Loggly. It's one that I used in a startup that I was working with. It's very cool because you can set up all sorts of queries and then based on certain conditionals, say fire off an alert. And an alert can then have different endpoints. But oftentimes, we just have an SMTP server, and we want to pipe some data through there. So what I've done over here is I've got a Docker Compose file. So you can actually check out the source code, Docker Compose up, and it'll set up Elasticsearch, Cabana, Mongo, and a fake SMTP server, which will just write out to disk. so we can check what's going on. And that's running in this tab over here. So for whatever reason, the email logging works perfectly in Windows, but trying to run it in Ubuntu results in an error. But it does actually connect through to the SMTP service, as we'll see in the log messages over here, or sometimes it doesn't. There you. So you can see, like, it's invoking the SMTP server and then saying that it can't connect to it. So I figured that out just before this demo. But you can trust me, if you load it up in Windows, you get an SMTP thing written to the disk. I think it has something to do with log levels, permissions in a Linux-based file system. So you can see that's owned by root, but I'm running it as root, and the other thing, Docker's running as root, so it should have worked, but it doesn't. Anyway, like I was saying, logging to email is generally not a great practice. You kind of want a layer of abstraction on top of when an email gets sent out, so you can do a bit more complicated stuff. Another anti-pattern I often see with people and doing email-based logging for their errors and their warnings is they create an Outlook rule and put all of the errors and warnings into a file in their email, and then it's like, well, what was the point of that? Because you're only checking that every now and then. And you know, if you look at how we are moving in terms of productivity, a lot of times, like, I'll only have my email open once a day. So email becomes not such a great mechanism for picking up those sort of errors. But there are a lot of people who find it very useful. So then we've got the sort of Rolls-Royce of logging, and that's the Elastic Stack. Previously, the Elk Stack. Has anybody here worked on that before? Oh gosh, so you'll know if I'm talking absolute bullshit. All right, well, there we go. So Elasticsearch is a really great way to store your log messages. It's also got a lot of really awesome other applications like text searching. Did anybody here use Lucene back in the day? So if you've got an MS SQL database and you've got like books or other products that you're storing and you want to do some text analysis on the descriptions so that your search actually results in your customers finding your products, Lucene was the absolute best for that back in the day. I'm not sure if it's still in use. You guys can talk to that. But it does really, really interesting things with n-grams and other text mechanisms. So an n-gram is basically when you take a word and you break it up into its constituents. So if I open up a notepad and we say test, and we break it into a 4 n-gram, it's test. 3 n-gram is test, and then EST. Sorry, that bracket should be over there. Oh, not there. So each of the components looks kind of like that. And then if we break it into a 2-gram, you get 2 ESST, that sort of thing. And that allows you to then index each of those. So while a person is typing, you can do type aheads with a single lookup, as opposed to a contains or a starts with or it ends with. And then an edge n-gram, you basically just take out the ones that are not there. And that's how a lot of the text searching on sites like Amazon and that type of thing work. But what does this have to do with logging? That sort of comes later. First, we have to get our data into Elasticsearch so that we can actually start doing all of this analysis on it. So the Elastic Stack is made up of a few components. The first one being Elasticsearch, and that's where the data lives. Then there's different ways of getting your data into Elasticsearch. Before it was Logstash. Now they've got the Beats libraries, which they've got a bunch of different heartbeat type things. So you can send your CPU, memory, all of that on a heartbeat into Elasticstack. You can also do log shipping. So if for whatever reason you can't directly, or you don't want to write all of your logs directly to Elasticsearch, you can write them to the file system and then you can ship them. So you can say, like, every 30 seconds, send the logs across. So that's great for existing applications where you've lost the source code, but it's mission critical, and it's writing to the file system, and you need to send those logs so you can actually see what's going on. So you can use the full stack for that. And then on top of it, they've got a visualization tool called Cabana. And Cabana is a GUI-based analyzer or visualizer for your logs. If you have got the paid-for version of Cabana, you can actually then also set up the rules and the alerts, and how they actually will notify you. So you can plug in your Twitter feed again, or whatever it is that you need in order to get notified at the appropriate time. Cool. So in our Docker Compose file, we set up Elasticsearch running on a specific machine IP, in this case it's localhost, and on a port, and we inject a super secret password and username combination for us to access it. And then if we go to our browser, if we visit that URL, if I close that, is it going to stop casting?
Close that one, yeah.
Okay. If we go to our, just go to the index, we'll see the fact that it is up and running. And then we can start dumping some data in there. So let's just go and take a look at that. No, where were we? Node. So we dumped some stuff into Elasticsearch. I've had to put in a bit of a wait timer to make sure that it flushes, because if it's running in memory, what it does is it sends them in batches as opposed to each log message to fix the latency, not the latency, to make sure that you're not sending thousands of requests into your log server at one time. So again, we're using Winston to do that. What we've done, we've created an Elasticsearch client using the Elasticsearch library, and we pass that client in to the Winston transport as it expects it. So all of the rules for how to do authentication and that sort of thing are stored in the client, and we just set up the rules for how our logs are going to work over there. And then we log stuff, and you'll see I've got my super hacky set timeout of 5 seconds to make sure that the stuff actually gets flushed. I tried setting the flush interval, but I'm not 100% sure why that didn't work so well. So we've now dumped some stuff into Elasticsearch, but how do we actually query it? So for those of you who've worked with Elasticsearch, you'll know that there's a RESTful API, but it's written by a bunch of developers who don't really understand REST. So there's a lot of anti-REST. There's a lot of anti-REST patterns that they've used, but it's a standard now, so it's okay, right? So anyway, we got this is Postman, for those of you who might not be familiar with it. Really awesome tool for checking out REST stuff, testing your REST APIs. So we saw, like we saw in the browser, we can get, if we just go to the root, we can get back some information about the server. We can get a list of indexes. These are like your tables or your collections in other data stores. And you'll often see what will happen is there's a prefix, like my awesome app, and then a dash, and then the date. Because what you can actually do is you can group indexes together, and you can have them with a time to live. So your indexes will automatically clean themselves up after a set amount of time, which is quite useful, because then you don't have to have a calendar reminder to go in and clear out the logs from your server. And it still allows you to aggregate and query on them. So we've got a bunch of, I can't zoom in at this point, but you can actually see there's my awesome app over there. And what you'll have in Elasticsearch is it's not completely schemaless like Mongodb. There's a mapping, and a mapping can have a property that's an object, and that part is schemaless. But you if you're going to be doing a lot of searching on your data, you want to set up these mappings so that it actually allows you to do those queries in an efficient way. So if you do not set a mapping, it will set a mapping for you, and you cannot change that mapping without dropping and recreating the index. So you might want to go through a bit of trial and error on dev before committing to a final mapping. It's just JSON, so we can see over here there are some properties. We've got a timestamp, a version, some fields we might want to store, and there's all sorts of data types and rules around them. You can tweak these to do like really powerful searches later on, like the Lucene text-based indexing. And that's some of the really powerful things about Elasticsearch. But if you are just using it for your log messages, you don't have to get too fancy with that. You can then search through a mapping using a the query syntax that they provide. And there's also the Lucene syntax is supported on Cabana. So this is how you can actually get your data. Each piece of data that you get back, you'll see has a max score. So that's how close it actually matches your query, which is quite useful. So you can you get an order by that sort of makes sense, off the bat. So if one property matches out of 1, that's a 100% match. And you can actually see what the data look like and how it stores it with magical underscore fields inside the data. So that's kind of what it uses. So try not. I haven't tested it out, but don't call your fields underscore name of field if it happens to be something like type, because I'm sure they'll underscore it so you'll get underscore underscore type, but maybe not. Cool. And then you can also do a search through a post with a body and a query rather than a query string. And that same syntax we'll see later on in Cabana. And then you can also do some interesting things like subfields. So you can search where field.a.b.c is equal to this, or starts with this, or partially matches. There's all sorts of very interesting syntax things we can do with that. Cool. So then we've got Cabana. So let me just zoom out a little bit. So I've logged in, and the first thing you see when you log in is that you need to create an index. So let's just go ahead and delete this. You can see I was playing around with this before you guys got here. Delete. So if we just go to Cabana, you'll see this is the first thing that it presents you with. We're not currently tracking any of the indexes that exist within Elasticsearch. You should tell us which one to start tracking. So if we look at our app, we are prefixing all of our logs with awesome app. So you'll see there's an index pattern over here where it's got a standard wildcard. So we're saying any logs that belong to awesome app, we want to see them together. And we can create then a timestamp. And I will create that over there. And now you'll see it's automatically tried to pick up how what the various fields are that you're posting through based on what you've got in your data already.
Just a question on that. Can you do an index where you don't, like, can you just put asterisks? I mean, sometimes it's annoying to have to look for...
Well, there's a lot of system indexes. So if we look at the indexes that are included by default, get all indexes, there's a monitoring-es-6, triggered watches, monitoring Cabana, watcher history, Cabana watches. So if you did that, you would probably get a bunch of false positives in your log messages. Yeah, and then what's going to happen is the guy next to you is going to be like, oh my gosh, that's so cool. I want to put my application's logs in Cabana, but I don't have a server. Can I use your server? And then you start shipping all of your application logs together because that's where you want them, so you can do cross-application searching. And now it's like, we've gotten horrible. So you probably can just put an asterisk, but you don't want to, I suspect. Cool. I see there is an edit button here. And I wonder if that will actually change the mapping without dropping the data. But in the experiences I've had, you generally want to have your mapping done as best as possible up front. And then you're kind of good to go. And this tool is really powerful. So if you've got BAs on your team who want to get some useful analytics out of it, or data scientists, or maybe you've just got an interest in that yourself, you can go ahead and do that. So there's a discover feature over here where you can pick a specific index pattern that you've previously saved, and you can sort of see, okay, well, what in the last 15 minutes, you'll see over there, what are the log messages that are currently in the system? And you can say, okay, well, in the last 15 minutes, these are the messages, and they've got these fields on them. And you can use the Lucene query syntax, which some of you might be familiar with from Lucene, to actually go ahead and do text searches, which is slightly different from how we do the searches on the REST side of things. And there's a whole little guide that you can go to. I am plugged into the internet, and that'll tell you, like, you know, how can you do that, how to do that. But you know, searches on standard text, so you can find the errors in your system, which is generally what you want at 12 a.m. on a Saturday. And you'll see there's the fields over here, so you can actually add them and say, like, well, I want to look at that based on this, and you remove them. So you're like, okay, well, let's take a look at the genres. So here's a log message with a genre of dash, which means you probably want to log a ticket with your developers and say, hey, stop logging genre of dash when there's no genre. Just use an empty array. And you know, you might want to then go ahead and add also the titles of the movies to sort of figure out how those relate to each other. There's also the very cool visualizer on there. This interface has changed quite significantly between version 5 and version 6 of Cabana. In version 5, you got the alerts and everything for free. In version 6, they're trying to upsell you, so there's a lot more fancy stuff, but you need to pay for the alerts. And you can go through these and you can click on, like, let's make a pie chart. I never remember the syntax for this, so I'm probably going to bugger it up on a specific term. So we can go with genre. Genre keyword, based on the count. Add sub-buckets, no. Anyway, you can play around with the visual in your own time. It's left as an exercise for the reader. And you can do some really interesting things. Once you've made those graphs, you can pull them into a specific dashboard. So you can create like a dashboard for your CEO, and a dashboard for your BAs, and a dashboard for you on a Saturday night. So you can then go in and drill down. There's timeline, which basically is a timeline of all the things that happened in your log messages. So you can basically see when things are coming in. You can do response times. There's a machine learning button. I've clicked it. I haven't yet understood machine learning, so it's obviously broken. Maybe they'll fix it in the next patch. You can do interesting things with the graphing and the dev tools. So you can add those patterns in there. So like we saw where we posted through a body, you can also type your queries here. And the nice thing about typing them here, so you'll see there's a query where the field title matches phrase star. So if we run that, we get back a total of 4 hits. We get back Star Wars Episode 6, 7, Star Trek Beyond, because we've posted through duplicate messages. And you can actually, over here, you get some sort of IntelliSense, which is quite useful as well, which you don't get in Postman, so this is pretty cool. And you can then build your queries on here. Just remember, it is going to include all of the built-in library stuff. Cool, and that's Cabana. I can go on with that for ages, but let's not. Then one thing to note for those of you who are using Winston, what's actually happening is Node is a single-threaded application. So what you're doing is you're tying up your application thread dealing with logs. So what you should actually be doing is go back to what we started with in the beginning, write things to standard out, write things to standard error, and use a pipe, and pipe it to Pinot. And Pinot can then take care of it. So we'll take a look at that. So you can use Pinot in a very similar way to how Winston works. So here, this will basically just give you the pretty print and that sort of thing. So we've got some JSON over there, and we've got some colorized error messages at the top over there. So Pinot is great. By default, it just writes to standard output and standard error. The very powerful with Pinot is instead of transports that live inside your app, you just simply use Unix and Unix's built-in pipe command. So we will then say, let's kick off that script over there, pipe it to Pinot Elasticsearch. Here I'm passing in a hard-coded username and password. Please do not do this. You can do a simple environment variable, which I was a bit lazy and should have done. And I pass it in the details of my Elasticsearch cluster. And we can then, no, I don't want to do that. I want to do npm run, no, stupid touchpad, npm run pipe. What that'll do, you see it still writes out to the console. So great when you're debugging. But on your production server, it's going to, or on your production application server, it's going to pipe those. So the Node.js thread can now continue doing your business logic, whereas a new operating system thread will then pick that up and ship those off for you. The other great thing about Pinot is it is massively faster to get your application booted up than Winston. So if I should have had this open, Winston versus Pinot performance. We'll load some graphs. So just from a philosophical standpoint, if you are running a C# application and you've got thread pooling and all of the other interesting things, you don't have to worry about that so much. But the great part about Node.js is it's non-blocking I/O, which you've now blocked by doing logging. So also, if you are running your Node application in something like PM2 or Forever, you want your application to boot up pretty quickly in case so you can scale it nicely, scale it up and down. So let's see, has this got the little graphs? No, this is not the right link. I think it's on their GitHub page because comparative advertising. So yes, that is logging in Node.js. But what about the browser? How much time do we have? Not much. So with the browser, you've got some options. Pinot actually has a browser version, so you can ship those off to your Elasticsearch server if it is externally accessible. If it's not, you might want to write a little node proxy. Simply send that REST request through to your node proxy and then dump it into Elasticsearch from there, or Mongodb, or your file system. So we were writing a React Native application, and the Android logging is not super great. It's hard to actually tie up a workflow to an actual log message. So what we actually did is we used some monkey patching, hooked into console.log, and we shipped all of those log messages across. There's a lot of your gut instinct when you look at monkey patching console.log, so that for those of you who don't know about monkey patching, you can actually override the default console.log, keep a reference to what it used to be, add your own code, and then call what it should be. So, some people might not feel comfortable with that, but if you've got somebody's Node package manager, Node module that you've installed via NPM, they might have used console.log inside there. And that information might be relevant just before the error that you're getting. If you instantiate your own logger and only send those log messages across to your aggregated logging, you might miss that information. So overcome your fear of monkey patching and just go ahead and do it. So here's the Pinot page, and if we Winston, benchmarks for Winston, they had graphs the other day. Anyway, we'll look at the text. So benchmarks for Pinot.info hello world. You can see with Winston, quite slow, 2 seconds, whereas with Pinot, 269 milliseconds. So if you believe the hype, and I've seen it in a production app, it sped it up quite a lot, at least shaved off at least 10 seconds from the boot up time, which was an app that was connecting to Mongo and establishing sort of a network cluster thing going on. Cool. Does anybody have any questions on logging? Comments?
How many Saturday nights have you spent without logs?
Oh, so yeah, back in the day, it was a lot of Saturday nights without log. And we always deployed on like a Friday or a Saturday because that's a good idea as well. So, so many nights. And then, if you're writing .NET apps and you don't really know how logging works, you're stuck looking in the event viewer and then realizing that you never actually implemented that logic, and it's sadness. So then you have to look in the IIS logs, and then you have to try and remember where those live, which is always fun.
Sometimes you have apps and stuff that are using queues, and multiple queue workers are listening to the same stream, and they're doing the same jobs pretty much. How would you recommend that you can kind of filter out the logs so that you know that one queue is working on this job and another one's working on the same job but for different contexts?
It's kind of the same way that I do it in the browser or in the client. It's called a correlation ID. So if you're in HTTP world and sending a REST request, there's a specific header for it. It's x-correlation-ID. So before you create the request, what you would do is you construct a GUID, using UUID or some sort of library. So you make a GUID and you assign it to that request. And that request then goes to the server. When it comes back, you can sort of tie the two up as well. Anywhere, if you've got like a microservices architecture or some sort of distributed architecture, you can follow it based on that correlation ID because it's unique. If you have multiple workers, for each job, you can create a correlation ID, assuming there isn't one already. So we used Azure queues, which give you a unique identifier for each job on the queue off the bat. So that's one way of doing it. But you definitely need to make some sort of unique identifier if your queue doesn't provide it for you. But I'm sure like Kafka and Redis and all of them do. Yeah. Cool. Anything else? Cool. I'm going to plug my Twitter. So if you want to be offended, you can feel free to follow me on Twitter. It's @ExigentCoder. So exigent circumstances. So if you bash down the door because you hear screaming, that's that. Follow me there. I tweet about rockets and stuff, and the occasional coding practice and stuff. And
Three shameless plugs. I was only going to